Today we're going to talk about why Tums, the antacid, works and how it works. And so our topic is acid-base reaction with gas formation. And we're going to stick with acids to start off with here. And so let's start off with taking an acid. And it could be a strong acid, such as the 7 strong acids. It also could be a weak acid. And we're going to react that with a metal sulfide. Now, metal sulfide is going to take, a sulfide is S1 minus charge, so it could be any metal that is bonded to this metal sulfide. So this could be an example. Let's take some hydrochloric acid solution, and let's react it with some sodium sulfide. And we'll make this a solution as well. Okay, so essentially what we're going to do here, I'm going to scroll this down a little bit here and give myself some more room, is we are going to we're going to have a double replacement reaction occurring. So we have the hydrogen and the sodium switching spots. And so we're going to rewrite this as NaCl, which we know is going to be aqueous because of our solubility rules having the presence of the sodium. And we're also going to produce H2S. Now, one thing that we'll need to remember that H2S is a gas. It's called hydrogen sulfide. Hydrogen sulfide gas, and it has this very characteristic smell. The characteristic smell is rotten eggs. Now, if you've ever been around any like hydrothermal vents, Yellowstone, Lhasa National Park has a lot of these. A lot of times you'll smell this characteristic rotten egg smell, hydrogen sulfide gas being released out of those hydrothermal vents. I'm just going to balance this guy really quickly here. Throw a 2 there, and let's see, put a 2 in front of sodium chloride. There we go. Now we're balanced. Now let's go ahead and write this as a net ionic equation. So take our HCl, and obviously this is a strong acid. It's one of the 7 strong acids, so we're going to ionize that. Sodium sulfide will also ionize. Make sure we put those correct charges on there. Sodium chloride as a product is going to ionize. And our gas does not ionize, so we do not ionize gases. There we go. So there's our complete ionic equation, and we're going to go ahead and cross out our spectator ions. So sodium is a spectator ion, as well as chloride is our spectator ion. So we can rewrite our net ionic equation as H plus S2 minus yields H2S gas. And I'm going to go ahead and balance this. Put my state symbols of aqueous in each one of those. And so there is our net ionic equation for the formation of the sodium sulfide gas. Okay, so the next topic we're going to talk about is an acid. And again, could be a strong acid or a weak acid with a carbonate or a bicarbonate. So either of these guys, and often these guys are, well, of course, they're going to be bonded with a metal ion that's going to make them soluble, or sometimes they'll be bonded with a metal ion as a solid, as we're going to see in our example. So what we're going to do is we're going to take a weak acid, and that's going to be acetic acid, which is the main component of vinegar. And it's a weak acid again because it does not ionize readily 100% of the way. We're going to we're going to react this with sodium hydrogen carbonate, or sodium bicarbonate, which is also known as baking soda. And if you've ever done this reaction, like when you were a little kid and you made a volcano, you reacted vinegar and baking soda, and you know it bubbles all over the place. And so let's find out what that is. So what's going to happen is, again, we're going to have a double replacement reaction, hydrogen and sodium switching spots. So we're going to form sodium acetate, and we are also going to form H2CO3, which is carbonic acid. Now, this is going to be aqueous. Now, the funny thing happens with, let's talk about this carbonic acid for a second. This is very unstable for the most part. So the bubbles that you saw, if you've ever tried this at home, vinegar plus baking soda, you saw bubbles. They were actually carbon dioxide bubbles. So what happens is this reaction immediately decomposes into carbon dioxide and into water. Carbon dioxide is our gas, water is our liquid, and there we go. So what we want to do is, even though we do have a double replacement reaction producing carbonic acid here, immediately decompose into CO2 plus H2O. So we often will just rewrite this equation as acetic acid plus baking soda or sodium hydrocarbonate produces sodium acetate plus CO2 plus H2O. We won't even write it as carbonic acid because of the immediate decomposition of the carbonic acid. So let's go ahead and write this guy in net ionic equation. And in net ionic equation form, we're going to have our HC2H3O2, and we're going to leave it together because it is a weak acid. Our baking soda was a solid, so we leave solids together as well. We're going to ionize the sodium, and we're going to ionize the acetate ion because they are aqueous. We're going to have carbon dioxide gas, and we are going to have water as a pure liquid, and so we're going to leave that guy together too. So really, we don't have any spectator ions in this reaction because of the way things work out. So there's our net ionic equation for this reaction. Now, I did promise you at the beginning we would talk about how Tums, the commercial product that is sold so that if somebody who has a, let's say, an acidic stomach, if you want to get rid of that acidic stomach, which often can cause heartburn and things like that, and the acid in your stomach is hydrochloric acid. So what Tums does is Tums is calcium carbonate in a solid form, and there's some other things in there as well, but majority of it is calcium carbonate. And so when a person eats a tablet of Tums, what's going to happen is double replacement reaction that occurs in your stomach. And so you're going to get calcium chloride in an aqueous solution, and you are also going to get carbonic acid, H2CO3, which we now know immediately decomposes into CO2 plus H2O. So CO2 gas, and that might make you burp a little bit, and water in your stomach. Tums is actually advertised as providing calcium. And it does provide calcium. It provides calcium in the form of calcium ion. And calcium is good for you. It builds strong bones and teeth and things like that. So let's go ahead and finish up the rest of this net ionic equation. So obviously hydrogen and the chloride is going to ionize. Calcium chloride is a solid, so we're going to leave that together. And then we'll take a quick look. It looks like the chloride ion is our spectator ion, and there is our net ionic equation. Let's go ahead and clean this up real quick. See, H plus CaCO3 solid yields the calcium ion plus CO2 plus H2O liquid. And this is what occurs in your stomach, and this is what neutralizes a bit of the excess hydrogen ions in your stomach that can cause things like acidic stomach or heartburn or things like that. Okay, and that's today's talk on acids and bases, or excuse me, just acids and how they can produce gas-forming reactions.